A positive integer divisor of 12 factorial is chosen at random. So the probability that the divisor chosen is a perfect square can be expressed as m by n, where m and n are relatively prime positive integers. We need to find what is m plus n. So if we consider 12 factorial, so 12 factorial, so first we need to, so the question is asking about the number of divisors which are perfect squares and number of divisors which are divisible by, which divides this 12 factorial. So that means, so 12 factorial if we prime factorize. So by using Legendre's formula, we know, so like first in its prime factorization, we have 2 to the 2, 3, 5, 7 and 11. So we know that 7 and 11 only occurs once and 5 occurs twice. So but for 2 and 3 we can use quickly Legendre's formula. So if we use Legendre's formula, 12 by 2 plus 12 by 2 square. So highest power of prime p in n factorial. So that is 6 plus 3 plus 1 plus 0 plus 0 and 1. So basically 10. And highest power of 3 would be, so 12 by 3 plus 12 by 3 square plus and so on. That is nothing but 4 plus 1 plus 0 plus and so on. So that is 5. So therefore 12 factorial is nothing but, so 12 factorial is nothing but 2 to the power 10 into 3 to the power 5 into 5 square into 7 into 11. Now we need to find number of divisors and we also need to find, so basically the question is asking about probability that a divisor is perfect square. So that means we need to find the number of divisors which are perfect squares divided by the total number of divisors, divided by total number of divisors. So total number of divisors and number of divisors which are perfect squares, we can find like first any divisor of, or like if we consider like we have a direct formula like 11 into 6 into 3 into 2 into 2, but we can just see like how we are getting that formula. So if I consider 12 factorials prime factorization, 2 to the power 10, 3 to the power 5, 5 square 7 into 11. So any factor, so any factor has, any factor of 12 factorial rather. So any factor of 12 factorial has its prime factors as 2, 3, 5, 7 and 11. So that means any factor of 12 factorial, so I can write it as 2 to the power a, 3 to the power b, 5 to the power c, 7 to the power d, 11 to the power e. And any, so basically a can take the values from 0, 1, 2 and so on till 10. B can take the values from 0, 1, 2 and so on till 5. C can take 0, 1, 2, D can take 0, 1 and E can take 0 and 1. In the same way, any perfect square factor of 12 factorial will be of the form 2 to the power a, 3 to the power b, 5 to the power c, 7 to the power d, 11 to the power e, where a can take only even values. So 0, 2, 4 and so on till 10. B can take 0, 2, 4. C can take 0 and 2. D can take 0. E can take only 0. So that means number of factors is having 11 into 6 into 3 into 2 into 2 possibilities. So these are total number of factors, of which the factors which are perfect squares are nothing but 6 into 3 into 2 into 2, because we are having 6, 3, 2, 1 and 1. 1 into 1. So therefore, the probability that the divisor is perfect square is nothing but 6 into 3 into 2 into 1 into 1 divided by 11 into 6 into 3 into 2 into 2. So that is nothing but 1 by 22. So that is our m by n. So the sum would be 23. So basically, we are using this. So any factor of 12 factorial will have its prime factors as 2, 3, 5, 7 and 11, because if the number itself is having 2, 3, 5, 7 and 11, it can't have 13 as its, the factor of 12 factorial can't have 13 or 17. It should have only those prime factors such as 2, 3, 5, 7 and 11. So therefore any factor will have those. So that's how we wrote the composition, and then we try to write different possibilities for A, B, C, D and E. So based on those possibilities we found the perfect squares, like how many divisors will be perfect squares, how many divisors are there. So we got 6 into 3 into 2 number of perfect square divisors and 11 into 6 into 3 into 2 into 2 as total number of divisors. So if we divide this, we'll get the required probability, which is 1 by 22. So the sum of the numerator and denominator would be 23. So therefore option E is correct. So that's it for this video. We'll meet in the next video.